So previously we discussed parallel and series configurations of batteries, and we discussed parallel and series configurations of resistors. So previously we discussed parallel and series configurations of resistors, capacitors and batteries. Now what we're going to do is look into a slightly more complicated case. So we're going to look into combinations of resistors, but combinations of resistors in terms of cross-wired. Look at this, isn't this lovely? So what we're going to say here is, how do we solve this particular circuit? As you can see, we have 10 different resistances, some of them in series and some of them in parallel. And we're starting out with a nice complicated one here to show you how something that looks horrendous is actually relatively simple if you view it correctly. So first of all, let's start off over here. What have we got here? Well, we have a 10 ohm here. Starting from the right hand side, we're going to try and calculate the total resistance of this circuit. So we've got a 10 ohm R8 and we've got a 2 ohm R10. These two are in series with one another. These two in series are then in parallel with this particular R9, which is 6 ohms. So RA, this whole section of the circuit, will be essentially, if we do 1 over 10 plus 1 over 2 plus 1 over 6, and that's essentially what we're doing here with the cross multiplication system, is we'll get 4 ohms. That means this RA is now a 4 ohm resistor. So we can substitute that into our circuit. So what we now have is a 6 ohm resistor, an 8 ohm resistor, and a 4 ohm resistor. We're going to say this whole section is resistance B, RB. The 4 ohm and the 8 ohm added together, RA and R7, will give us 12 ohms. They are then, if we combine them over here, in parallel with this 6 ohm. If we do 1 over 6 plus 1 over 12, we will end up with a 4 ohm resistance. So now RB over here is 4 ohms. So you should see now how we're simplifying this. R5 is 4 ohms. So 4 plus 4 gives us a total of 8 ohms in series. That's in parallel with another 8 ohm resistor. So 1 over 8 plus 1 over 8 will give us 4 ohms. RC then, this whole RC 4 ohm combination, is in series with this R3, which is 4 ohms. So RC plus R3 will give us 8 ohms. There's our 8 ohms. Now, this whole section here, RD, this combination, will be 4 plus 4, which is the 8 we just calculated, plus R2, which is another 8. Those will be in parallel. So 1 over 8 plus 1 over 8 will give us another 4 ohms. So we've taken that whole complicated circuit and figured out that all of that complexity comes down to an effective resistance of 4 ohms, which is pretty disappointing considering how many resistors we had in it. Someone badly needed a 4 ohm resistor. So that whole combination came down to 4 ohms. And we can add that now to our 6 ohm resistor in series. So RD plus R1 gives us 4 plus 6, which is 10 ohms. So the total equivalent resistance of that whole circuit that we saw before is just 10 ohms. And that's what you should do with every one of these problems, is approach it logically and simply. Decide what's in series with what and what's in parallel with what. So essentially what we'll say here is we'll add our series together, add our 10 and our 2 and put those in parallel then with our 6. That will then be something you can add to the next phase and the next phase. Don't try to make one huge all-encompassing equation for the entire system in one shot. That's how things go wrong, and that will make a mess. Make sure you're breaking the circuit down piece by piece, doing the calculation, and eventually you'll come to one single all-encompassing resistance number for your entire circuit.